A CT scanner may look simple outside, but inside, it is highly controlled and can cost hundreds of thousands of dollars. It uses specialized industrial alloys, and its 3-ton frame must be cast with precision. Even small defects could affect performance and safety. Inside are thousands of ceramic crystals, and components weighing over 1,000 kilograms, rotating 3 times every second. And that is only the baseline. So when Philips, Siemens, and GE control so much of the global market, how does Canon Medical hold its position? In this demanding industry, the CT gantry frame is built in a way that resembles an MRI gantry here at a Canon Medical CT facility. Before casting begins, workers first pour tons of foundry sand into the mold. Then, with an iron rod, they level the surface to the correct angle. For lifting, iron chains are attached to both sides. When the overhead crane pulls upward, the 2 sides of the mold separate cleanly under the lifting force, but some material still remains on the surface. So the worker carefully removes the leftover sand by hand, because the sand contains a strong binder. Once it has been compressed, the inside becomes extremely solid. Whether it is molten iron or aluminum, the metal can flow in and take the shape of the grooves. But a CT scanner is a precision machine, so the workers use brushes to clean the surface. Anything that falls away is only excess material. Only the finished mold shape matters for Canon Medical. To be more precise, Canon Medical was once Toshiba Medical, the same Toshiba Medical division that Canon acquired back in 2016. And in the medical imaging field, Canon has built a stable market position. If you work in hospitals or purchasing, you may have heard of GPS plus C. Those letters refer to 4 major medical imaging brands. GE Healthcare leads the group, alongside Siemens from Germany and Philips from the Netherlands, and the C stands for Canon. Together, these companies hold a large share of the global CT market. This also shows how difficult this industry is to enter. In China, United Imaging has also become a major name. Together with other local makers, it has taken a growing share of the domestic market. Local sales are especially strong, while GE, Philips, and Siemens still remain powerful. Each holds its ground firmly, and decades of experience make them hard to challenge. Next, black rubber seals are placed in the mold. Then, along the lower section, a white binding agent is applied to the sand. This helps prevent molten aluminum from leaking out. Once the top and bottom sections are locked together, the adhesive seals the gaps tightly, leaving enough open space inside. For the aluminum casting, the aluminum is a specially prepared alloy. It is lightweight and non-magnetic, so it will not interfere with nearby motors, sensors, and electronics. Besides aluminum, titanium alloys can also be used in higher-end gantry systems. They are chosen when strength, weight, and long-term stability matter even more. For smaller clinics, machines at this level are a major investment. After another 30 minutes, the molten aluminum reaches about 720 degrees Celsius. That is the right range for this casting process. Unlike iron, which needs a much higher temperature to melt, aluminum can be kept between 700 and 720 degrees. It also solidifies much faster. After workers pour the metal from 2 crucibles, they leave the casting to cool for 4 hours. After that, they use tools to break away the inner sand mold. At this stage, precision matters. First, the frame is secured with steel cables on both sides. Then it is placed on a platform. That creates high-frequency vibration. The vibration helps loosen the sand packed tightly against the aluminum. Once the machine starts, it takes only about 10 seconds. For the rough frame to appear, From inside the mold, the sand is now removed, and the frame can move to the next stage. Meanwhile, workers attach a steel chain to the aluminum frame. Not too long and not too short. It must fit the crane hooks perfectly. Careful viewers may notice that the hollow frame has several sections. For example, the widest and longest base supports the detector. Directly above it sits the X-ray tube. Even the cables and cooling pipes have dedicated spaces. The aluminum pillars on top are temporary and will be cut off later. Now, workers in hard hats use air hoses to clean the frame carefully. Most of the sand has already been removed, but many tiny particles can still hide inside the frame if they are not cleaned out. The next cutting stages cannot be done properly. The 20 or so pillars of different sizes are vent channels left from the casting process. The better the mold can breathe, the more smoothly the metal can flow. But at the end, workers still need real skill to cut each section accurately. The leftover scrap metal will not be reused for this casting. Any weakness in the structure could create serious problems later. Remember, this is a heavy frame, built for a high-speed machine, rotating 3 times per second. A crack is simply not acceptable. Once you understand that, it becomes clear why this scrap is not simply melted and reused. To strengthen the frame further, it also goes through a heat treatment process. It is not heated directly in an electric furnace. Instead, it is treated in a liquid bath. Aluminum has a narrow, safe range. If the temperature rises too high, it can damage the aluminum permanently and weaken the structure. That is why every step is handled with extreme care. One more thing. This is still only a rough casting. It will be sent to Canon Medical for further work. In another workshop, unfortunately, those next steps are not shown, because much of the process remains confidential. And finally, a quick clarification. CT scanners use carefully controlled X-rays, so the goal is always a clear medical image. With the lowest reasonable exposure,